This project is sponsored by PCBWay. From April 15 to June 15, PCBWay is organizing KiCad PCB design contest on the occasion of the launch of KiCad 10 with enhanced features and improved workflows. There are 3 grand prizes of $500 cash plus a Raspberry Pi 5, as well as a participation award, a Raspberry Pi Pico 2. Review the official rules and selection criteria, submit your innovation design, and you could be our next winner. PCBWay and KiCad look forward to seeing your creativity in action. Hello! Variable frequency oscillators, VFOs, are commonly used in radio transmitters and receivers, especially super heterodyne receivers where they allow the adjustment of the operating frequency. They are essential for amateur radio communication systems and test electronics. In several of my previous videos I have shown you several different ways to create VFOs, which basically differ in the way the generated frequency is displayed. This time I will again describe a way to make such a device, but now significantly different and more practical than the previous ones. However, its manufacture is much simpler and cheaper because we do not use a display or even a rotary encoder, which is a basic part of every VFO. And all this is achieved thanks to the use of a smartphone in the function of controlling and displaying the generated frequencies. Now the device is extremely simple and consists of only 2 inexpensive components: an ESP32 microcontroller board and Si5351 clock generator module, which is connected to the ESP32 with only 4 wires. The frequency is generated directly on the CLK0 output of the signal generator. Using a smartphone as user interface instead of a classic LCD is a great way to get a graphically rich display without spending money on expensive touchscreens. The ESP32 is perfect for this because it has built-in Wi-Fi and enough muscle to simultaneously run a web server and communicate with Si5351 via the I2C protocol. At first the challenge was to achieve that smooth rotation effect without lag, so I started with the ESP async web server library, which allows control via WebSocket, but several bugs appeared, so I continued with the built-in Wi-Fi and WebServer.h libraries, which are quite sufficient for optimal control and operation of this device. Then I gradually created a visually beautiful graphical interface with an LCD display, a central rotary knob, and more functional small buttons with different functions. First, let me explain to you the method of starting and all the functions of this hybrid variable frequency oscillator. When we turn on the hardware part, on the smartphone we search for a Wi-Fi network with the name Si5351 VFO final complete. Then we connect to that network with the password VFO 12345678. Now in the web browser we enter the address 192.168.4.1. We open the browser. And press search. This image actually represents a web interface through which we will control the hardware. A great advantage is the fact that we do not install any applications on the smartphone at all, but only this is a web page. Thus, there is no danger of introducing malicious software, and the compatibility with different smartphone models is unlimited, taking into account that the only requirement is to activate a web browser. Now, by pressing the button of the display, full screen mode is activated. And now the instrument is ready for operation. The LCD display shows the starting frequency, which is predefined in the code. The upper left part of the screen shows the modulation type and the band, and the upper right shows the step with which the frequency changes. At the very right bottom is the signal bar, which in real receiver or transmitter display the signal strength. This bar is connected to GPIO34, and by applying a voltage signal to this input, the display is activated. Below the display is a large round knob centrally placed with which set the desired frequency. As I said earlier, the knob moves very smoothly and the data is transmitted almost instantly to the device. In reality, during operation there is no noticeable delay at all. Several small functional buttons follow. First, the amateur bands areas are defined. Below them is the step button, which is very often used and therefore larger. Below step are the mode buttons AM, SSB, USB and FM. And at the bottom are the 4 memory buttons. If you want to memorize a frequency, we first press the number at the top of the display, during which the memory buttons start flashing, and by pressing one of them, the frequency is memorized. In case we want to delete all previously memorized frequencies, we press the right side of the LCD display. Now let's see how this device works in real conditions. To do this, I will connect a small oscilloscope to the output of the hardware part, on which we will observe the change in frequency and signal shape. And finally, a short conclusion. This project proves you don't need expensive touchscreens to have a beautiful professional grade interface for radio projects. By combining ESP32 and Si5351 with your smartphone, you can build a highly functional retro-styled VFO that fits right in your pocket.